We're going to work through this donuts problem together. This is attached or linked in the in Schoology on the page where you found this video. So go ahead and pull that up, and I would like you to work through this with me at the same time. Break even, I wouldn't say it's overly difficult, but there's a lot of steps. And so it is important that you kind of follow along, you get the rhythm of doing a break even, and you do this with me. I don't think watching me do it is going to benefit you at all. I would like you to do it with me. So we're going to work through this problem step by step or question by question. So the first question is asking us to calculate the unit contribution for the donuts. So we're just going to go ahead and start there. So unit contribution, as you learned in the lesson, is just the price minus average variable cost. So in this case study, it gave us price right here, okay, and average variable cost is right here, okay. So I'm going to go ahead and just calculate my unit contribution. You do always have to show your work, even though that's pretty simple math. So unit contribution will be $1.25, and it is important that you label it appropriately. This is monetary, so it's dollars. And as I've told you before, it's also important that you make your answer stand out, especially when you're doing a lot of math on one page. It's easier if you can make your answer obvious. All right, so that's letter A, easy enough. B, calculate the number of donuts the firm has to sell each month in order to reach break-even. So that's basically just asking you to calculate break-even quantity. And since I am doing this with you, I'm going to choose to use the unit contribution rule, which is the total fixed cost divided by unit contribution. And we can keep it simplified like this because we've already calculated unit contribution here. In our case study, we were given fixed costs of $10,000 per month. Okay, so I'm going to go ahead and plug that in over here to our formula. So it'll be 10,000 divided by $1.25, which was our unit contribution. This is going to give us a break-even quantity of 8,000, and since it's quantity, this is donuts. And I know they spell donuts weird in this case study, but that is how it's spelled in this case study. Okay. All right, so again, easy enough. Make your answer stand out. Going on to the next question. Calculate the monthly safety margin for Myers Donuts. Okay, so that's just asking us to do the margin of safety. And as we learned in the slides, margin of safety is the demand, how much they're actually selling, minus the break-even quantity. In this case study, demand is given to us as 9,500. She sells an average of 9,500 donuts each month. So we're going to plug that into our formula. 9,500 is our demand minus our break-even quantity that we calculated, which was 8,000. So our margin of safety is 1,500, and margin of safety is a quantity. This is a demand quantity minus a break-even quantity. So margin of safety is a quantity, so it's 1,500 donuts. Side note, since margin of safety is positive, that means that the donut shop is earning a profit, right? Because they are selling more than they need to break even, so they're making profit. This just means that they can drop sales in 1,500 donuts and still be safe. So it's kind of their safety net in case there was a slump in sales. They kind of know where they stand as far as like how many sales they could lose before they were in the danger zone. So that's what the margin of safety is representing. Moving right along to D, using the above answers, create a fully labeled break-even chart for Myers Donuts. This is where it's going to get a little trickier, a little more complicated or complex, I guess. because there's a couple steps we have to do before we can actually do the chart for the break-even. So that's where we're going to start. For a break-even chart, the magic number is going to be 3. You're going to calculate 3 coordinates, and then you will plot 3 points on the graph, and then you will draw 3 lines through those coordinates. So the first thing we need to do is calculate 3 coordinates, and the 3 coordinates we need to calculate is the break-even point, the total revenue at demand point, since we were given demand, and then the total cost at demand, since we were given demand. Now, just a side note, we were given demand in this case study. We did have to calculate margin of safety, so all that has to be represented on this chart. If we were not given demand, then obviously we couldn't use demand in our calculation, and we couldn't use demand in our break-even chart. If we were given something instead, like maximum capacity, like the maximum donuts they could possibly make was like 11,000 donuts, then that would be like the limit of your graph, if that makes sense. But for right now, we were just given demand, so that's what we're going to use here. Our break-even point coordinate is going to be made up of the break-even quantity on the x-axis. X-axis is quantity or output. And on the y-axis, it's going to be the total revenue or the total cost at the break-even quantity. Because the y-axis is going to be the monetary value, so the costs or revenues. Okay? If you decide, whichever one you decide to calculate, you're just going to replace Q with the break-even quantity. And it says total revenue or total cost because they should equal at break-even. So you don't need to calculate both, or you shouldn't need to calculate both, because they should equal. So if you're going to use the total revenue formula, that's just the price times the break-even quantity. Again, you're just replacing Q in that total revenue formula for break-even quantity. And if you're going to use the total cost formula, that's just the total cost formula that we know and love, total fixed costs plus the average variable cost, replacing Q with the break-even quantity. Okay. Moving right along, we've got our total revenue at demand point. So the x-axis value is going to be the quantity, which is demand. And the y-axis value is going to be the total revenue at demand. So we're going to use the total revenue formula, price times quantity, replacing quantity this time with demand. And lastly, we've got our total cost at demand coordinate. So our x-axis value, again, is going to be demand. And our y-axis value is going to be the total cost at demand. So we're going to use the total cost formula, total fixed costs, plus average variable cost times demand. Okay, so we're just using these same formulas that we've been using all year long, and using the the x value for Q in that formula, right? So we're just replacing Q with whatever we have on the x value. All right, so now let's go ahead and calculate these coordinates for our donuts, for our donut problem. So we're going to go ahead and start with our break-even point. So we're going to have our x-axis value, which is the break-even quantity, which we calculated up here as 8,000 donuts. So that's going to be 8,000 for our x-axis value. And then it's going to be the total revenue or total cost at break-even. I like to use the total revenue formula because I think that's easiest, 2 variables versus 3 variables. I'm lazy when it comes to math, so I would rather do 2 variables. So that's going to be $1.50 times the 8,000. So the price was $1.50 times the quantity, which is 8,000, and that's going to get us 12,000 as our x-axis value. Whoops, wrong lid. Moving right along to our total revenue at demand. So in this case study, our demand was given to us as 9,500. So my x-axis variable is going to be 9,500. And for the y-axis is just going to be the price, $1.50, times the demand, which is 9,500. So that's going to give us, 14,250 for our y-axis value. Lastly, we have total cost at demand. So again, our x-axis value is going to remain demand, 9,500, and our y-axis value is going to be our total fixed cost plus average variable cost times demand. Our total fixed cost was the 10,000 plus the average variable cost, which was 25 cents, times demand, which is 9,500. Okay, let me calculate that really quickly. Okay, that should be 12,375. Okay, so those are our three coordinates that we're going to be plotting on our graph, and that's what we're going to use to scale our graph as well. From these three coordinates, we can tell what our highest x-axis value is, so we'll know how far we need to scale our x-axis, and we'll see what our highest y-axis value is, so we know how large we need to scale our y-axis. So the largest x-axis value we have is demand, which is 9,500. So we know that our x-axis has to be scaled from 0 through at least 9,500. And then our y-axis value, that's the highest, is total revenue at demand, the 14,250. So we know that our y-axis has to be scaled from 0 through at least 14,250. So this brings us to actually drawing and scaling and plotting the graph. I'm going to go ahead and cut this video off, and I'm going to start a new video for just the graphing piece. So just bear with me and tune in to the new video.